Nice evening. Last evening was wonderful. Congratulations, Ashutosh. As a theme of this summit, I have chosen to speak something related to taking lab prototypes to commercial products. This is one among the activities in the lab the last couple of years. This has got to do with the material glass. When I say smart window, it is not the Windows software, it is to do with the actual glass, the windows around here. So this innovation relates to how the windows can be made smarter. There is a concept of zero energy building. You can imagine this fancy building, how much energy it would be consuming through the day. The zero energy building, by definition, should not be consuming any energy. The net zero energy should be close to zero. And indeed, there are such buildings in the world. There are a couple of them where the people claim that the overall energy consumption is clearly zero. As you can see, most of the energy consumption relates to heating, ventilation, air conditioning, and I don't have to stress more that the windows associated with any given room play a very big role, because you want sometimes the sunlight to come in, warm you up, and sometimes you want to prevent the sunlight. You want to also have privacy in control. And of course, lighting, for example, look at the lighting here. And outside we have very bright sun. Instead of that, we have we're using a lot of electricity for towards lighting and air conditioning. So these are the considerations which take a very serious turn in the zero energy building concept. And so let me just focus on the window aspect. What one likes to have is the window which is operable the way it is in a going flight. So these are the aircraft windows. There are no plastic shutters. They are rather electrochromic technology-related windows, and the passenger has a choice of turning on the color, including making it completely opaque or completely transparent. So with this, you don't have curtains, and you can even have master control. The air hostess will announce now that all windows, people have to open the shutters and all. That is not required. With one master stroke, they can have all the glasses made transparent. So such is the liberty, such is the leverage these glasses can offer. But you don't see them all over the place. There are a couple of places where even interiors, for example, they are controlled by another technology called PDFs. So this is an example again where when the user wishes to have opaqueness or privacy, you can just turn on the switch and the window glass turns opaque. So it is, whatever I'm speaking, it has implications with respect to the lifestyle. It has implications towards how we make use of the energy and many other aspects related to that. Well, there are a dozen technologies. I'm not going to do a survey of that. Whatever I just showed you was the polymer disperse liquid crystal technology related. Earlier, the Boeing flight, it used electrochromic technology. And there are many other parallel technologies, and there are also benchmarking parameters. What you have to pay attention is one particular row here, the power consumed to keep the device in the on state. This is actually a display device. Okay, so just that there are no pixelation here, and we can turn its color to different shades. So the power is of the order of a few watts per meter square, and that's kind of energy consumption to make the window operable. What I'm going to show you is a technology where the energy consumption becomes essentially zero. Towards the end of my presentation, you should be getting convinced with that. And where are the bottlenecks? Why we don't see PDLCs and electrochromic windows being used in the domestic setup, in, even in the hotel, anywhere? Why we are not seeing? The main reason is the electrode part. The electrochromic active material is rather affordable, but the electrically conducting, transparent conducting electrode, which is made use in these devices, is the most expensive. And that is the ITO, which is a well-known substance with well-known material, and that's exactly what is used even in touch screens, in everywhere, whatever optoelectronic devices you come across. We made an invention nearly a decade ago. This is related to how we can replace ITO and bring something very, very affordable. So you take a piece of glass and we find a technique of building up very, very fine nano mesh over it. And that nano mesh can be of any material like aluminum or tin and all that, very, very affordable materials. And having made that, this is optically transparent while electrically highly conducting. And this we took it forward to, actually towards technology. That's the piece of the talk I'm talking. Where we began, we just realized these kind of glass panes, which is just about a square inch. And as we moved on in the lab itself to make prototypes, we translated the technology to PET sheets and different types of substrates, glass, quartz, and all that. You can see here a sheet of PET which is coated with the thin nanowire networks, and you can see it's essentially transparent. We could go up to this level in the lab, and by then we had lots of publications, even related to, I'm not even talking about the electrode part, just about the smart window application part. And then these are the publications and patents and whatnot. And we also went ahead actually to make prototypes. Having made an alternate transparent conducting electrode on glass and PET and all, can we now realize all optoelectronic devices, whether it is a touch screen, defrosting, defogging panels. Ashutosh has seen it, he has visited the lab. So many of those prototypes we made, this is only to attract the interest of our Indian industry. In fact, I must tell you, there is not a single industry relevant to this particular area whom I have not spoken. I have really gone and knocked the doors everywhere. People should take interest in this. Many industries came forth, even visited, even exchanged the devices, took forward for certification, whatever, and that's where it went up to, and the struggle was on. Somehow, what I want to tell in this summit is, Indian industries are rather conservative, particularly with respect to a knowledge product. It is not only enough that you bring the technology readiness level beyond 5 and 6. They really want it to be positioned at 7 and 8 so that they can commercialize. And that works extremely hard for innovators like me and you. Okay, so this is my expression, this through my experience I have come to know of this, and that really saddens me. Why Indian industry? There are some industry people also sitting here, our friends. Why Indian industries are so conservative? While I could connect very easily outside. My efforts were on, even global. Through Indo-French Center, we got connected to a German industry near Munich, known for precision printing. They print currency notes actually. They took interest in our research and we signed up. In 1.5 years, they translated whatever innovation we had on just about a square foot, product. They translated to something which is roll to roll. So you can see the sheet, PET sheet held there. This is coated with aluminum nanomesh. It is transparent, as you can see. The sheet is for 45 ohms per square. Okay. Now this is a product on Amazon through this particular company, for which we had to sell our rights, we had to transfer the rights. It is no longer with our country. And this is a sad story actually. But as an innovator, I was happy that something could get translated, but we couldn't do it within the country. Well, there have been little success stories working with Indian industry as well. That is to do with when the same invention done on glass. We have partial support from HHV UAVAC from Bengaluru. They came forward, joined us in a project, again a government project, and we could translate that to glasses. So we set up a sort of semi-pilot plant. This is a plant which is operational. Ashutosh only inaugurated that in 2019. It is still operational. We do produce these pieces and supply to some DRDO labs and other industries in India, trying to raise their interest and trying to build various types of prototypes, what would be of interest to them. Several calculations have been done, everything has been worked out, including one of the defense labs has taken it, one of the prototypes for certification. And whenever we do anything, we actually want to demonstrate. For example, this is a PDLC related device, and these devices are functioning and one can visit and see them. Still, I want to go back and tell you in the next 2 minutes that we couldn't make a breakthrough with respect to the energy consumption. As I said, any of these products utilize energy to function. You may have avoided curtains, you may have brought in fantastic control with respect to transparency, but still there will be energy required, however minimal it is. So the struggle was on. We wanted to realize something which doesn't consume any energy whatsoever. Here it is. So this particular, which is a more recent one, in the last 2-3 years we have realized this product, which doesn't consume any energy at all. So this is based on microfluidics. Me and Ashok have worked on surface wetting, de-wetting, so on and so forth. In fact, whatever lessons I learned, those days I have taken them forward, Ashok. Even now I keep publishing papers, citing your papers on de-wetting. And so this is one related to microfluidics. So you have a glass surface, make it rough, then it becomes rough, it scatters light, and light doesn't pass through, it becomes opaque. And this is typically used in fancy things. You want to create some level of pattern or whatever on glass. People use sandblasting or laser writing and whatnot. But when you fill up the same nano trenches with the liquid which can match the refractive index of glass, suddenly those trenches disappear. Okay, very, very simple principle. But it takes a lot of deal in terms of realizing how the fluid flow will be and how you withdraw the fluid when you don't want it to be there, so on and so forth, and surface wetting and all those considerations come in. And to show you a prototype working here, you can see this is a tall window, and by pushing one button, you can actually fill the device with the whatever fluid it is, and it renders it to be transparent. And then when you don't want it, you can, how do I go to the next slide? Yeah, so these are the 3 states. Translucent, and the transparency drops to just around 3% or something, absolutely no light passes through. And you can also have a curtain effect up and down, and you can render it to be entirely transparent. When I make it transparent and don't show you anything of the remaining top curtain, you can hardly make out, it looks like just like a plain glass itself. Okay, and where is the energy? What with respect to energy, what it is? You see some buttons there say that you're utilizing some energy. No, you can actually make it manually if you want to. Just use a hand pump, you can make the fluid go in and come out. So to function, to keep on or off, you don't need energy, but to put in, take out, if you fancy, you can have a small motor function. That's about it. So this one, again, I talked to a lot of industries in India, and no one bought the idea. Because in the first place, we are not glass makers. We only replicate, reproduce what is being done elsewhere. So again, I had to speak to people who are glass giants globally. And one came forward, that is Saint-Gobain, Paris, and they connected us to the Saint-Gobain R&D Center in IIT Madras Tech Park, and with whom now we have the 4th phase translation going on. So they are supposed to be making now 1,000 prototypes to be placed all over India with the dealers and check the customer response to that. And if successful, probably it will become a full-scale product. And we made only this type of product, whatever is shown with the size. And now they have taken it to the full glass size. The largest glass piece what you can see around, that's the size they are working with, and they have been quite successful. We learned a lot. We even sponsored a PhD. In fact, the student just completed his PhD, and he's again joining the team with Saint-Gobain. While I thank the collaborators all through, I must mention that it has been quite a struggle to attract attention of the Indian industry. I think at least through this summit, we can convey the message that it's high time that we have to take it differently. Things have to change. Thanks for listening.